Hi, grade 10s, welcome back. So we are busy with the third test or exam type question for analytical geometry. We're going to read the description, just going to study the diagram, and then only are we going to look at the questions. DEF are the vertices of triangle DEF. Okay, we can see there's a triangle forming on the Cartesian plane. Nothing funny so far. The equation of EF is that. Okay, so they are saying that the equation of that straight line is equal to y is equal to minus 5x plus 9 equal to 0. That is clearly not in the standard form for a linear function, which is y is equal to mx plus c. Now, we can obviously go put that in standard form if we want by isolating the y, but there's no need, just yet. Let's see what they're going to ask. And then they give us the equation of DE. There we've got line DE, and they give us that equation as well. And again, not in standard form. Let's quickly study the diagram and see what missing information is there. So we've got the whole of point F, we've got the whole of point D, and then for coordinate E, we don't have X or Y. E is the missing coordinate. All right. Then, there isn't really anything else there. There isn't much going on the diagram. However, E looks like it is 90 degrees. Now, we can't say, oh, it looks 90, so it is 90. No, but maybe there's potential that they're going to ask us something like that. I don't know. Okay, let's look at the first question. For the first question, it says, determine the coordinates of E. Okay, so of course, they want coordinate E. If I look at that, the fact that there's two missing things in coordinate E, both the X and the Y, is quite tricky. We were not given the length of lines. We were not given midpoints. We need to work with what we've got, grade 10s. And if I look at that, I am thinking, let's just extend that to make it a little bit clearer. So those two lines will obviously, they can carry on. But that just helps us clearly see that point E is actually a point of intersection between the yellow and the pink lines. And we've got both their equations. So how do we find the point of intersection, grade 10s, between two straight lines? Well, we have to make the equations equal to each other, or we are using simultaneous equations. So you need to refer back to lessons on functions if you feel a little bit lost with this, how to find the points of intersection. And also you need to refer back to the equation sections and specifically look at simultaneous equations for what we are about to do. Now, the way I do it is not the only way to do it. There's different ways that you will be able to solve X and Y, just as long as you do mathematically sound things. I can, and you can, go write both these equations. I'm going to make that equation 1 and that equation 2. We can go write them in standard form. And then it would look like that. Y is equal to blah, 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 blah. And then y is equal to blah, 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 blah. And then we just make those two equations equal to each other. We can definitely do that. But I'm not going to go with that route this time, just because I am avoiding working with some silly fractions for the pink line there. Now, I'm not saying we should be scared of fractions and that we should always avoid fractions. I'm not saying that. I'm just going to go with a different route. So if I take equation 1, I can isolate the y there. I am going to isolate the y by putting this one in standard form. And when I do that, it would look like that. Then I'm going to just copy over that second equation. I'm not going to write that one in standard form. All right, but what am I going to do? I am going to, this is equal to y. Y is equal to that. So in this equation, whenever I see a y, I'm just going to go plug that in. So wherever I see a y, I go plug that in. Why do we do that? Why is that helpful? Because now look what we accomplished. We created an equation only with x's. And now we can solve for x. So if we multiply that in, it will be 25x and then minus 45 plus x plus 19. And now we can simplify that, put our like terms together. When we do that, we've got 26x and if we put those together, just quickly reached for my calculator. If I add 19, that will give me negative 26. And obviously, we can see what the answer is going to be. So x is equal to 1. Nice. So we already know that coordinate E will have an x value of 1. But we are not done. We need to go calculate the value of y. So we are going to substitute x equal to 1 into which equation? I'm thinking equation 1. Let's substitute it into the first equation. So into the first equation, in the place of x, I'm going to plug in a 1. And when we do that, that would be 5, take away 9, that would be negative 4. So there we've got our x value and we've got our y value, and therefore that gives us coordinate E, the point of intersection between the pink and the yellow line. Whoops, we found them. So that would be 1 and that would be negative 4. Perfect. Again, refer back to functions and simultaneous equations if you feel like, what on earth did we just do? That's 5 nice marks, I think. All right, let's see what's next. I just copied the diagrams. And again, if you haven't grabbed a copy of the workbook, the link should be in the description. If you just want to write this down and create that copy for yourself. Let's look at question B. Question B says determine the equation of the line. So we need to find the equation of a line. Again, we know the equation of a line is in this form. We need to find the equation of a line that is parallel. Ooh, the moment that you see that idea of parallel line, what do we know about parallel lines? I hope you can answer that. So we have to find the equation of a line that is parallel to EF. Okay, so we need to find a line that is parallel to EF and it goes through the points 0 and negative 3. So 0 and negative 3 is maybe somewhere over there. So that is a point on the line. So I am estimating that that parallel line would be something like that if they are parallel. So it is parallel and it goes through the point 0 and negative 3. Okay, and we have to find the equation of that line. Now, currently on that line, we only have one coordinate. We only have 0 and negative 3. One coordinate on a line is not enough to be able to find the equation. That is a special point on the line, though. It is the y-intercept. So in other words, we can just plug it into the place of C because that is our y-intercept. Again, your linear function knowledge. So we already found that C value over there. Now we still need to find our gradient, our M value. What other piece of information can we use? Well, they told us that those lines are parallel. What do we know about lines that parallel? They share the same gradient. Lines that are parallel share the same gradient. Do we have the gradient of line EF? I feel like in the first one, yes, they gave us the equation of EF in the first one, didn't they? EF is that one that we wrote, y is equal to 5x minus 9. Y is equal to 5x minus 9. There is the equation for EF. And there we also have the gradient. There is the gradient, the coefficient of x, our m value. So the gradient of this one is equal to 5. So therefore, since the lines are parallel, this gradient will also be 5. So the equation of the line is 5x minus 3. There you go. That's it. Okay, I like this question so far. It's a little bit different. Let's look at the next question. 4C. Determine the coordinates of G, the midpoint of DF. All right, I'm going to use this one at the bottom. Let me scroll down a little bit more. No, that's not going to work. So what are we trying to find? We are trying to find the midpoint of DF. So DF, I am estimating it would be more or less over there. Let's have a look. We've got coordinate D and F. That's perfect. So we can find that midpoint. Well, to find G, to find the midpoint, we take the two X values and we're going to put them together. So it's negative 4 plus 2. And we divide that by 2. And then we take the two Y values and we're going to add those. And then we're going to divide it by 2. That would then be equal to, we just need to simplify, negative 4 plus 2, negative 2, that should be that. You can double check it. You can also check it on your calculator, of course. And this one would also be negative 1. Let me just also double check that. Yeah. Okay, perfect. There we have coordinate G. Next up, for D, we've got 2 more questions. So for D, it says that determine the lengths of the sides of triangle DEF. So they want the length of DF, DE, and EF. Okay, let me just quickly put in our coordinate for E there. What was it again? 1 and negative 4, I think. Let's just double check in case. Yeah. Okay, so that is all the information that we need. We've got the 3 coordinates, and we are going to have to use the distance formula 3 times. So it makes sense that our mark allocation there would be 7. Remember, high mark allocation doesn't always mean difficult sum. It just means multiple steps. So I am going to find, it doesn't matter obviously which one you start with. I'm going to start with finding the distance of DF. And for my distance formula, I think that's a bit small. Let's substitute carefully and make sure that we don't make silly errors there. So I'm going to subtract my 2x values. So I've got negative 4. Oops. I feel like my pencil is too thick. Maybe that one is better. Negative 4, and I'm taking away, or maybe not, maybe it's just me. Negative 4, and I'm taking 2 away. And then negative 3, and I'm taking 1 away. Okay, perfect. So let's take it from there. If we simplify, negative 4, take 2 more away. Negative 6, if I square that, that would be 36. That one, if I square that, it would be 16. So the distance of line DF would be the square root of 50. Then the distance of DE. Plug that into the distance formula carefully. If we look at D and E, I'm taking my X values and I am subtracting them. And then I'm taking my Y values and I am subtracting them. So see what happens over there. There are my 2 Y values and I'm subtracting a value that is already negative. So just be mindful of what's going on over there. If we simplify that, that would be 25 because inside the bracket I get negative 5. And if I square that, it gives me 25. And inside this bracket, I'm going to get negative 3 and I will get plus 4. So that would give me 1. And if I square that, it would just be 1. So the length of DE is the square root of 26. I'm just leaving them in surd form. One more. The distance of line EF. Let's substitute that in carefully. Getting good practice in for the distance formula. So I'm taking my 2x values and I am subtracting them. And then I am taking my y values and I am subtracting them. Again, I'm taking away a value that is already negative. Now we just need to simplify that carefully. Let me just put that in there. DE and then the distance of EF. So that would be 2 minus 1. That would just be 1 squared, which is 1. And then plus, that would be, if we look at that, it would become 1 plus 4, which would be 5 squared, which is 25. So this one will be square root of 26. So let's just have a look there. Distance of DF has square root 50. Okay. DE is the square root of 29, and then the distance of EF is the square root of 26. Again, you see that these are actually the same. They have the same side length. Okay. Well, we did what they asked. Let's see what's next. With the next one, they are asking us, what type of triangle is triangle DEF? And give a reason for your answer. Well, we basically answered that in the previous question. We saw that two of the side lengths are the same. So now the question is, do you know that those names for triangles, how we name triangles according to their sides? We can have a triangle with three different side lengths, and that will be a scalene triangle. Then we've got a triangle with two sides that are the same, like the one that we're dealing with, and that is your isosceles triangle. And then you can get your triangle where all three sides are the same, and that would be an equilateral triangle. So we are going with isosceles triangle, isosceles triangle, isos triangle. I doubt that I can spell isosceles. Now I do need to try isosceles. I believe that that is actually correct, but do check. My spelling can be terrible. So it is an isosceles triangle. What type of triangle is it? It is an isosceles triangle. We need to give a reason for our answer. Well, we knew that it's an isosceles triangle because two of the sides have the same length, which is the square root of 26. And there you go. We are done and dusted with this question. I hope it was helpful.